What are we doing here?
What do you mean?
Why are we even doing this? We've been doing this for 10 minutes and I don't even see any new muscle.
Oh my gosh, that's not how it works, ding dong. It takes time to grow muscle. Hypertrophy is the most common form of muscle growth, and it's the increase in muscle cell size through the splitting of myofibrils. This can be done through strength workouts like this one.
This is not to be confused with hyperplasia, which, while rare, is the formation of new muscle fibers caused by endurance workouts.
That sounds good and all, but I think I'd rather be a couch potato.
I wouldn't do that if I were you. See that, dog? Because of her recent surgeries, she has dealt with muscle atrophy, which is the degradation of muscle. Without strong muscles, even the simplest of tasks, like walking, can prove difficult and tiring.
That sounds like fake news. I bet you guys don't even know how muscle contraction even works.
The most important part of muscle contraction is the sarcomere. As you can see at the Z line, the actin filaments, also known as the thin filaments, connect to the Z line. We also have our titin, which then connects to our myosin, or thick filaments. Those are connected to the myosin heads, which help with muscle contraction and movement.
Hey! A sharp knife like that is a hazard.
After the brain sends a signal to the muscle groups in question, a series of things need to happen to make the muscle contract. Calcium ions that are released from the sarcoplasmic reticulum binds to troponin, which causes tropomyosin to uncover the binding site on actin. The myosin head is then able to bind to actin, forming a cross bridge. What follows is called the power stroke, and ADP, an inorganic phosphate, is released. When ATP binds to the myosin head, the cross bridge is broken.
The first type of muscle fiber you can use while exercising, which Alex is demonstrating, is the slow muscle fiber. It is found in red muscles. It has a high resistance to fatigue. They're used first for normal muscle contractions, and endurance athletes such as marathon runners and bikers tend to have more of these type of muscles as well.
The second type of fibers is fast fibers, which are involved in white muscle, and they have a lower resistance to fatigue and are used for more forceful contractions. So athletes like bodybuilders, sprinters, jumpers will have more of these, as well as the average person. So like Alyssa is demonstrating. So do you understand now?
Yeah, it makes a lot more sense.
So that means you're going to start exercising with us now, right?
About that.
Up next on the exercise channel, yoga.
After a quick word from our sponsors.
Hi, my name is Dr. Hazard, and I'm a proud sponsor of the A Girls because they are all going to get A's.
Whew. Alright guys, time to end our yoga session with some deep meditation and breathing.
Wait, if we're doing yoga in order to work out our muscles, why do we have to do deep breathing? That doesn't use any muscles.
You don't ding. Of course it uses your muscles.
She's right. When you take a deep breath in, that's called inspiration. During inspiration, you use some muscles. You use your external intercostal muscles and your diaphragm. Your external intercostal muscles are the main muscles involved in expanding your rib cage so you can take air in.
Okay, but what about when I exhale? There can't be any muscles involved with that. All I do is breathe out.
Of course we use muscles when we exhale.
Exhaling is also often called expiration. During expiration, we use our abdominal muscles and our internal intercostal muscles. When you breathe out, your internal intercostal muscles pull upward so that your lungs can force air out. So you can see, you do use your muscles when you breathe.
Wow, I'm learning so much, but how do you remember the difference between intercostal and external intercostal muscles? They sound so similar.
Actually, there's a trick you remember. Whichever direction your hands point is the direction the muscles pull. So, come with me. If your hands are in your pockets, that's the direction your muscles are going, so down. And the E in the pockets represents the external intercostal muscles.
Okay.
Now, if you put your hands on your...
Anyways, let us continue our deep breathing exercise. Deep breath in. Deep breath out.
Wait, I have another question. What is the difference between breathing normally and taking a deep breath in and taking a deep breath out?
Oh, I know this one. There are different lung volumes that occur with the different types of breaths you take.
I still don't understand.
Here, I have a chart that might help.
This area right here is inspiration reserve volume, which includes the extra reserve volume when taking a deep breath. Right here is when you would take your breath. Right here is the expiratory reserve volume, which is when you would forcefully exhale, and this is what it would look like when you exhale.
This area right here between the dotted lines is the tidal volume. The tidal volume is the amount of air that is in your lungs when you breathe normally. And then this area down below is the residual volume. This is the air left over in your lungs after a forceful exhale, and this keeps your lungs from collapsing due to negative pressure.
Overall, this whole part is the total lung capacity.
Do you get it now?
I do! I love yoga so much!
Awesome! Alright, let's do some more yoga. Warrior pose.
Hi, I'm Lisa Douglas, and I too am a proud sponsor of the A-Girls. Thanks for watching.
Thanks for watching.
Thanks for watching.